Just to give you a background, I'm a geologist, and geology is my #1 passion, but I also am very interested in understanding how is the industry I work for and do my research for. So this is sort of like what we're going to be talking about today. So these are very obvious things that you all know. We've been talking about previous talks, they have been mentioned, but all of this that you're seeing here happened in less than 100 years. That we shifted in technology completely since we actually understood the power and the physical chemical characteristics of metals and raw materials. We're able to fly, to have high-speed trains, modern medicine, your laptops, etc. And of course, we know this part also, which are the consequences of this development, of the consequences of having a very nice and comfortable life. We have climate change, global warming, excess of CO2 in the atmosphere. We also know what happens with that. We know there's droughts. I come from Chile. We have some really bad emergencies sometimes about this. Forest fires, another one that is big in my country, or any kind of extreme weather event. And we're seeing this happen more and more and more often. We just saw it happen in Europe when we had the most extreme heat wave that has been recorded in the last few years. So there is a solution, and there's a classic solution that we've been talking about, that is the energy transition. So we move to renewable energy, energy that does not have any CO2. So we get rid of gas and oil, and we get rid of coal, and we move to things like solar, wind, or electromobility. And what you see there beside each one of these are different elements. Nearly all of those elements are metals. Metals where each one of these has a very specific function for a solar panel to work, for a wind turbine to work, to be able to have an electric bus, like the one we see up there that is actually in Santiago in Chile. So we need metals for this energy transition. So let's go back to the basics, because not everybody's in earth sciences here. What are metals? So we're seeing here a picture of the periodic table. It has 118 elements. Of those 118, 94 can be classified as elements, as metals or metalloids. We also classify metals when we have alloys, for example, bronze. But each one of these metals has different physical chemical characteristics that make them useful for very specific things. And because we're going to be talking a lot about this, we can see this last row underneath the main periodic table, and these are the rare earth elements. They go from lanthanum to lutetium, and we separate them in heavy and light rare earth elements. Just a little bit of background. So we use metals for everything. We use metals in construction. We use metals for electricity. So that's a lot of copper we're seeing in this photo. We use metals for modern medicine. My mom broke her hip some years ago, and thankfully she got a hip replacement with a hip made of a very specific alloy with titanium. So thanks to that, my mom is still walking and enjoying life. So metals are very important for modern life. And we consume metals. As we consume food, we consume metals. Just look at your phone. Your phone has more than 64 metals in it. Each metal has a different function. Is it for the circuit board, wires and connectors, battery, whatever? All of these is what we consume on our daily basis in terms of metals and raw materials. So where do we find metals? This is what I love, is actually looking for ore deposits and trying to understand how they form. So they form in different parts of the planet, of the crust, and it depends a lot of geology. And that geology depends a lot of tectonics plates, how they move, how they used to move in along, etc. So where we find deposits or bodies in general is not random. If not, it would be looking for a needle in a haystack. It has to do with geology. For example, Chile has a lot of copper because we are in a subduction zone. Because of the same reason, we have a lot of earthquakes, more than any other country in the world. We're very proud of that. But the thing is that metals are not democratic. If we look at a map, I'm sorry that the map is in Portuguese, but I just really like it. And you can see that some countries, some locations will tend to concentrate certain metals more than others. We see, for example, Brazil is the #1 producer of niobium. Chile is the #1 producer of copper and lithium, or at least in reserves. We can see that China has the largest amount of reserves of rare earth elements and also of graphite, and so on. So this means that if we need all these metals in order to make your phone work, in order for my mom to be able to still walk, we need to cooperate between different countries. Because what happens if we don't? And rare earth elements is a great example. So the first rare earth element mine that was opened was in the US. It was called Mountain Pass. Actually, now it has reopened. And we started using rare earth elements to have color TV. So actually the color on your phone, in your laptop, is because of rare earth elements. So time went by, and you can see in that chart, Mountain Pass closed. And by 2010, our only producer and processor of rare earth elements was China. 2010 is a very special year because China got into a diplomatic fight with Japan over an island. And what happened is that they cut the supply of rare earth elements, said they needed that supply for themselves. And you can imagine what happened with the price of rare earth elements. It skyrocketed. And that made us realize as a society that having one country that has all the concentration of a certain element that is strategic is not a very good idea. And one can see that after 2010 and until today, we see more diversification of who is mining and producing rare earth elements because we want to avoid another event as 2010. So this solution to the renewable energy is political, and we need to remember that. It has to do with geopolitics. It has to do with how we relate between different countries, and that's going to be very strategic, and you're probably going to be seeing it a lot in the news, and we have been seeing it a lot in the news and probably more in the future. So this is a chart to make everybody really scared, but it's from 2021, so things have changed quite a bit. So we have the solution of the renewable energies. Let's say tomorrow we transition 100%. Now we're all driving just electric cars. There's no more gas, no more coal. It's all solar, it's all wind turbines. This is the amount of metals we would need for that. And what you see in the Y index is the amount of times of reserves that we have nowadays. Okay, so let's start with copper. Copper is the one that we need the less for now. I would say we probably need more. We need at least 2.5 times the amount of copper we have nowadays. That means that tomorrow, we need to find 8 new Escondida mines, which is the largest copper mine in the world. We can see that there's rare earth elements, manganese, and then it gets every time more dramatical until we get to lithium, 40 times the amount of lithium we have today. Now, I will tell you, lithium, cobalt, and nickel are probably changing as we are talking because they depend a lot on technology. There's new lithium batteries that actually don't use cobalt, and they use less lithium. So those are going to be changing. But the first two, rare earth elements and copper, are probably going to go up, are going to stay right there where we see them. So of course, we'd be talking about recycling. Can we avoid this through recycling? To some point, yes, but not really. So we still need these metals. What does this, and if we look at how much is recycled, if we've been talking about this, less than 1/3 of the 60 most used metals have a recycling rate above 50%. And of those 60 metals, 34 have less than 1%. You can see those in red, and of course, we see the rare earth elements all popping out. So we're not really good at recycling at the moment. Therefore, this future demand projection, this cry of help, means that we need more mining if we want to transition tomorrow to this renewable energy 100%. So what happens when we look at mining? We can see that we were really good at discoveries of new deposits. This is copper deposits. But then, sort of like 2009 on, you can see that our discovery rate as geologists is getting worse and worse. and does not talk with the amount of budget that is actually invested in exploration. So we have one problem, that our discovery rate is not as good as before. We have another big problem, that even if I discovered 8 escondidas tomorrow, it normally takes 15 years to get that mine to start operating. That's an average between you find the first hole with mineralization until the mine is operating. So the whole energy transition is having a big problem with the supply of metals. And we actually still don't have the solution for that. So then there's this dilemma. We can do all this effort to try and get the supply of metals. But then this goes a little back to what Appa was talking about in the morning. For whom, and I would say, for what exactly? So in my head, because I'm an optimist and I used to be more of a dreamer when this whole idea of critical minerals and mining appeared, I would think that we want to do this because we want to level up. We want all the world to have the same life quality that we have in more developed countries, right? Is that what the energy transition means? Or it means that we all change our car to electric cars? Also, I started asking myself, who is actually getting all the raw material? Who's buying it? Who's processing it? And I want to really talk about one term today as a message, that is traceability. Can we trace the raw materials that we are consuming? Because I actually get to decide when I buy eggs if they're free range or not. Do I get to have any knowledge on where my raw material comes from? That's something that we will try and figure out. So who is benefiting? And I think this was talked about it in the morning. We can see, for example, electromobility. In my head, this would mean electric public buses everywhere. We see that a lot in Santiago in Chile. Very proud of it. But what we see actually is that if we look at the amount of electric cars that are being sold around the world, more than 60% are all sold and bought in China. And they'll include 100% electric and hybrid. And we can see there comes Europe, a little bit of North America. But I would expect to see electromobility actually doing a service as public transportation in different cities around the world, not all concentrated in one country, and hopefully not seeing that very horrible car that I'm showing there, and I hope I don't insult anybody, which is the last Tesla model that is sold in the US. In this chart, I find it's very interesting. It's from the World Economic Forum, and it shows, so it's very difficult to read from far away, and I know that, but think about it in colors. The oranges are mostly Europe and Northern Hemisphere, okay? And as we get more colorful, we'll start moving to Middle Eastern countries and African countries. And what we're seeing there is a ranking of the countries that have most advanced on implementing renewable energies in their electrical grid. And you can see there's a very evident color change from very orange to very colorful. And this makes me think a lot, why are we doing this? And I especially look at the example of Pakistan, because Pakistan, since 2024, had to transition to 100% use of diesel. So I would assume, as a person of the society, that this should be the first place where I would like to implement renewable energies, especially now that the price of diesel has skyrocketed. So then I got kind of start thinking, is the energy transition a first world luxury? In a certain point it is. And I think we talked about that in the morning quite a bit, but here we can see it also in numbers. Then comes the traceability of metals. What I'm showing here in this photo is from a book called Cobalt Red. It was a large and very long journal investigation that was done by the author called Siddhartha Kara. He won awards thanks to this, where he showed that it's impossible to trace that the cobalt that you use in your phones and your laptops is free of any type of illegal mining or child labor or anything you would not want to be associated to. It's impossible, as cobalt is mined nowadays in the DRC. And it's also not only traceability, but it's not only mining. So we mine, we get the material out, we concentrate it, and then it needs to be processed. It needs to go to a smelter. Somebody needs to be in charge of smelting and processing that material to afterwards sell the raw material 100% pure. So what I'm showing there is actually the smelter area of the mines of Bayanovo. This is in northern China, and is what we would call a sacrifice zone in terms of environment. It's an area that is heavily polluted because of this type of smelting. And what happens that we don't see this. Most of the time, we're not aware of it, but we are consuming rare earth elements that implicate this is happening. So again, this has to do a lot with our responsibility of knowing and wanting to know what we consume as a society when we consume technology and we consume having a very good life in general. And here comes probably one of my most interested discoveries that I've been thinking about lately. Who buys processed metals or raw material? Because again, in my head, we're doing more mining because we want to do this energy transition. We want to build more solar panels. We want to build more wind turbines. But after the smelter, after we have the raw material, do we really know who is buying it? So a lot of raw material goes into warfare. And you can see in that chart the amount of kilograms and thousands of kilograms of rare earth elements that need to be used for an F-35, for example, or for a submarine. So part of what we're mining of rare earth elements, part of what's happened in these sacrifice zones is also going into warfare. It's not only going into energy transition. So again, traceability. Who are we selling this material that is being mined, especially from those that come from countries that have mining, as is Chile, for example? Another piece of the puzzle, probably one of my newest favorite ones, are data centers. So we all are using AI. AI is a new revolution. And for that, we need these massive data centers. 80% of the metals that are used in data centers is copper. And the demand of copper is approximately going to go up at least 5% or more, sorry, 10% in the next 5 years, only because of the construction of data centers. So our demand of copper is going to go up, again, not because of the energy transition. Now we have another player in this game, which is artificial intelligence. And this also means that the US will need more copper and more raw materials. Data centers also use rare earth elements. And that's why you can follow the news. Every day there's now, I just saw news today of meetings between the European Union and China talking about rare earth elements and metals in general. And why? Probably because of data centers. Another one, and the last one I wanted to mention, is not a critical mineral, as we have known and we've heard the definition, but a critical one, a critical metal, which is gold. So gold, in a very objective perspective, does not have a very specific critical use in our society. But as a society, since the Roman Empire, we have given it a very important price. We use it as a commodity. We use it as a way of, something that we use in money. So before, banks used to have all their currency in gold physically, and its price historically is always, always, always going up. Investing in gold is always good. Why? Because it's a tangible way of having money. So nowadays, we have convoluted times around the world in general, and these are the times people will invest in gold, because it's way better to have something that is physical, like, for example, buying dollars or buying yens or whatever. So the price of gold have gone up. So with that, one would think that companies like Barrick, for example, that specialize in gold, are over the moon because the price of gold is really high. That is true. But then we get another problem. We get illegal gold mining. So nowadays, for example, in Peru, 28% of all the gold that is produced in the country comes from illegal mining. Illegal mining in South America is so profitable that it's even started to be more profitable than drug dealing. So these are mafias that are working in Peru mainly, in Colombia, and also in Brazil. And what they do is they just, smelt the gold, export it to certain countries that will then sell it as a legal piece of metal. And we have a whole world of illegal mining that is growing and growing and growing out of control because of the price of gold, which is a metal that really doesn't have a purpose besides just being gold. These are photos that a friend of mine very kindly shared with me. He was flying through the Amazon to go to a specific gold project, but of a company. And he sent me all these photos. You can print a star. The star shows where it is in Brazil. So in the middle of the jungle. And what we see are a series of all of those are illegal gold mines. These are all over the Amazon. You can imagine what that means in terms of environment. Also, ask oneself who is working there and how they're exporting that and allowing, etc. So we still have a role on all of this. So it's not all out of our hands. And I like to think about this. One is that we can really be better at recycling. I don't know how many of you have old phones in their house that have not been properly recycled or old computers. That used to be me, actually. Last year, I took care of it and went to a recycling center and recycled all my electronics. But we're not really good at doing that. And the other thing is that we're not that good at consuming in a conscious way. And again, I go back to food. We like buying organic food. We're worried about that. We like buying free-range eggs, plus they taste better. But for example, do we think about technology when we consume technology? And I'm showing this example of Apple, of the iPhone 17, which since last year, 100% of the cobalt in their batteries is recycled. So now they have no blood in their hands. All the cobalt is coming from recycled cobalt. How do they recycle the cobalt? Very easy. Try and fix an Apple phone that is more than 2 years old. The replacement pieces do not exist. So you actually have to trade in your phone to get a new one. And if you fix it before 2 years, the place that is fixing your phone has the duty of sending those pieces to Apple. So you are using recycling cobalt from basically a company that is making you buy their phones over and over and over again. So again, is our consumption that is making Apple a very profitable company? So we do have options and we can do something. And this is what I like to think about. The first one has to do with how we transport each other where we live. So if you can prefer public transportation, that is extremely important. We need to have cities that have more public transportation because we need less cars. We cannot just change all cars to electric cars. That would not make sense. So for me, an ideal world, the energy transition would mean a city with no cars. And a car is a luxury that maybe you rent when you go out on holidays. And all that public system of transportation is electrical, for example. A second one, think about traceability. What and from where are the raw materials that I'm consuming? This is a difficult one, but if you can, try and choose leaders who will have a proactive agenda on this subject, who are thinking about this. So I fortunately come from a country that has a democracy, and I would like to be able to vote for a candidate in the far future, because we just got a president elected, that is actually thinking about this. Who do we export our copper to and for what they're using it for? Am I okay with that or not? Because at least me, I'm super happy for our Chilean copper to be used for the energy transition. I'm not so happy that it's being used for warfare, for example. And then again, we are the consumers. We move the economy that also moves mining and raw materials. So as consumers, we have options. And in that sense, repairing is revolutionary. Try and repair before getting something new. I try to do it all the time, and crazy enough, every time is more difficult because our society is made for us to get something new when something old is damaged instead of repairing. And that goes not only for technology. I've been trying to find someone to repair shoes, and even that is difficult. So just to finish, I think it's okay to actually question the energy transition and how it's happening and all the nuances we can find around it. It's important. It's important that we ask ourselves these questions, that we ask ourselves, where is the raw material that is being mined? Where is it going to? Why we're doing what we're doing? And the second one, if you're against mining, this is a great time to find new enemies. You can look through all the production chain and recognize new problems. So it's not only mining, it's everything that comes afterwards that is equally important for the whole ecosystem of raw material production and consumption. So with that, I'm going to finish, and more than happy to take any questions or comments. Thank you.